Most new PLC programmers, they get this wrong. They rush to learn how to write programs. But is that what they should really be doing? We're going to dig into that question today. I'm going to share with you some things that I've seen in the field. I'm going to share my own opinion and my own idea about how you can accelerate your PLC programming skills that's going to save you hundreds of hours of frustration later in your career. Hello, my name is Paul Godinez. We're going to take an inside look at logics. So we're going to start with writing PLC programs. You know, if you're working, let's say on a small machine, maybe a conveyor, or a pump, or a single station, you know, writing code, that makes sense. You'll build a start button, a stop button, a counter, a timer. That makes sense, right? The upside is that you build a foundation and see how the rungs, tags, and logic, they all connect. The downside is that small machines are clean and they're simple. But in the real world, production systems, they aren't. Writing alone doesn't prepare you for the messy, layered, complex code you'll see in the industry. Now let's flip that. What if you start by interpreting programs? That is actually what you're going to face on a large, complex system. A packaging line, a transfer system, or a whole cell with robots and conveyors. Now suddenly you're staring at hundreds of rungs, routines, and add-on instructions. The upside is you see how professionals actually build the logic to handle the sequences, faults, and interlocks. The downside is it's overwhelming without some basics, some context, right? So what's the right path? After nearly 4 decades in manufacturing, well over 10 years in industrial automation with projects all over the globe, I've seen this again and again. The fastest growth comes from blending both of them. Here's the sequence I recommend. You know, go ahead and write some small programs first to understand the building blocks, timers, counters, start, stop circuits. Then move quickly into interpreting large programs where you can trace tags, follow routines, and see how a production system actually works. Because in the field, no one's going to hand you a blank PLC and say, build me something. They're going to point to a stopped production line and say, figure it out. That's interpretation. And here's the key. Don't measure your progress by how well you can write a small program. Measure it by how well you can interpret large, complex programs. Because in my opinion, anyone can build a start-stop wrong. But the people who succeed, who get hired, get promoted, are the ones who can step into a 500-rung program, find the section they need, and make sense of it. So how do you actually learn to interpret a program? I got a few ideas for you. There's a few methods that I've used that really work. Break it into sections. Don't look at the entire program at once. Pick one routine, maybe the auto cycle, maybe the safety circuit, and study it until you understand the flow. Write and test parts of it yourself. Take a small section of the logic, recreate it in your own project, and run it in a simulation. Writing even a piece of it helps you understand why it was built that way. Mind map the logic. Draw out how the inputs lead to the outputs. Sketch the sequence, the push button, motor start, timer, solenoid. Putting it on paper forces you to simplify the complexity. Trace the signals live. Go online if you're able to at Studio 5000, for example, and watch the tags change. Follow them through the program. This gives you real-time feedback that makes the logic actually come alive. Do these consistently, and you'll start seeing patterns. That's when these complex programs stop being intimidating and start becoming readable. You're able to interpret what's actually going on and why it's going on. It's also why I built my own interactive simulation lessons. They give you both sides a chance to write small foundational programs and the chance to interpret large running systems in a simulated environment without the hardware or the expensive software. If you really want to sharpen your skills, I'll drop a link below. You can try out some of our interactive simulations and see for yourself. This is a great shortcut to growing faster in this field. Thanks for watching. Hit the like if this has helped you, and subscribe for more lessons from the real world inside automation.